So if I'd like to invite the panelists to come up and take a seat. We're going to talk about innovation and production in this session, which is really great. Again, an absolutely crackerjack of a panel we've got for you today, some really amazing speakers. And before he sits down...
I'll come.
I'm actually going to invite Alexey to sort of just give us some opening remarks on this topic, if you'd like to sort of kick us off, Alexey.
Absolutely. Good afternoon. It's a pleasure to be here. And I'm really excited about all the discussions which have been going on today. My name is Alexey Ustinov. I'm responsible for Electrolysers business within Cummins. And now we have a new brand launched as Accelera by Cummins. Let me tell you a couple of words about the brand, Accelera. Cummins has over 100 years history in the diesel engine technology and components. And now a few years ago, we made a conscious decision to invest into the net zero technologies and also take the technology agnostic position. So to differentiate from the core business, the company made the decision to launch Accelera brand, which is net zero technologies. And this includes the fuel cells. It also includes the electrolysers, electrified solutions, including battery, e-axles, so anything what's related to the net zero type of technology, and hopefully more to come. A couple of words about Cummins as a company for people who don't know us. We've been founded in 1919, so we are not as old as Bosch, which celebrated 125 years in the UK. Again, congratulations to all our Bosch colleagues. The company was dealing with innovations from the day one, because the diesel engine and the associated technology was innovation at the time. And now it's a stable business, but we understand that we need to manage the transition, and we need to make sure that we are part of the net zero solutions going forward. 3 years ago, we purchased the company called Hydrogenics, which was a startup. With the presence in Belgium, that's where I'm based, and also in Canada. And as a typical startup, it had really great technology solutions, but not so much of processes behind. And our main challenge at the time was to scale up this, both from the product range perspective and also from the manufacturing. And initially, the reason to purchase Hydrogenic was more related to the fuel cell business, because we've been in the mobility all our life. And a couple of years ago, it became very clear that while fuel cells is important business to go forward, but the electrolysers will pick up much faster, and it will become significantly bigger business than what we expected. So what we started to do, we invested heavily into the expansion of the product range. We focus on PEM solution. We still have legacy alkaline. We increased the capacity of our existing facilities in Belgium and in Canada. And then two important things came. One is the Repower EU initiative, which was signed by the industry members back in May 2022. And that created the much more clear funding mechanisms in the electrolyzer space, and also in the hydrogen and renewable space of Europe. We made a decision to invest into the new greenfield plant construction in Spain. And this Spanish plant will be put in operation in Q1 next year. Then, it was really busy time, 2022. Then, in the middle of the year, US published Inflation Reduction Act. And that was a game changer. Just changed completely the whole thing. We recognized that our capacity in Canada will not be sufficient. Plus, because it's US funding, and for people who don't know the way it works, it's up to $3 funding through the tax credits per kilogram of hydrogen. Just think about it, if you know the cost, $3 a kilogram, that's a lot. So they stimulated the demand in the United States. And we invested into the brownfield conversion of our existing facility in Fridley, which used to produce power generation equipment. And that has been incredible success, because it took us 3 quarters to convert this plant, or part of this plant, from the power generation equipment into capability to build electrolysers. So all this takes us to up to 3 gigawatt capacity by the end of 2026, all these investments. Is it a lot? We believe it is. Is it a comfortable position for us to be in as a company? Yes, it is, because our order board is almost full. So we currently think about what else we need to do as a company to expand capacity. Again, comfortable position. Quite, I would say, clear view about what we're going to do in the future. But this last year did help us to take a look at the overall hydrogen business through the lens of one of the suppliers, because there are a lot. And we respect our competitors, we respect our other players, and we all face similar kind of challenges. And it's always good to talk about what these challenges are. Innovation, very generic term, but the reality is that the technology is not stable yet. There is alkaline, which everybody believes that it's sort of old proven technology, but there is pressurized alkaline coming. There is PEM, which is also, there is pressurized PEM, non-pressurized PEM, so there are some variety there as well. There is a possible disruptive technologies coming, possibly anion exchange membrane, solid oxide, so the timing of these technologies, then they will come into the production volumes, not clear. How disruptive they will be, not clear, but the technology is not stable. So the key for the industry is to continue to innovate. And we'll continue to innovate, because even what we've seen half a year ago now is different. And we believe that half a year down the road, things will change. So that's why innovation and technology leadership is absolutely critical. It's not all about the electrolyzer producers. It's also making sure that we partner with our suppliers. So it's a question for the whole industry to partner and drive economies of scale to innovate. Because without that, things will not change. Then, what are the challenges in the industry? There are a few. Actually, the list is long. The first one is the cost. The cost of the hydrogen continue to be pretty high. How it can be changed? It can be changed through innovation and through the economies of scale. How we can drive economies of scale as an industry? Well, here I would like to talk about the numbers. Because we see a lot of announcements across the industry about mega projects, gigawatts, in all over the world. But Repower EU initiative set clear target of 10 million tons of hydrogen to be produced in Europe by 2030, and another 10 million tons of hydrogen to be imported into Europe. Is it a lot? Let's talk more about it. What we've seen today about the UK, there is ambitions, to if I convert the gigawatt power, into around 5 million tons of hydrogen, by 2030. Yeah. Is it a big number? Difficult to gauge, right? Just for your information, the whole world produce and consume today, every year, 92 to 96 million tons of gray hydrogen. Just the scale. So then we talk about economies of scale and the need to create hydrogen industry. Suddenly you recognize it does exist. It's there. The only problem with this industry is that this existing industry is actually gray hydrogen with incredible CO2 polluting. Incredible level. So it's becoming a question of what we're going to do. Then, just to finish with the numbers, if you look at the amount of hydrogen to be produced by the projects which passed FID stage today, and we are in June 2023, it's 3 million tons only. 3. So there is a huge disconnect between what we see in the industry about the announcements. There is a disconnect also from the planning perspective and the setting the targets, and then you compare it to the overall production of the gray hydrogen, huge gap. So the only way to drive the economies of scale is not to put all the focus on the development of the new hydrogen industries, which I believe is important still. Developing the fuel cells, mobility, heating, others, absolutely important to make it happen. But the big elephant in the room, the reality, is the existing hydrogen industry, 92 to 96 million tons of gray hydrogen. And that's something which can drive economies of scale tremendously. And that's something which will help to reduce the cost in the industry. How it cannot happen? Well, obviously, it's a combination of effort. The industry should continue to innovate and reduce the cost. Should be regulatory solutions as well. All this is important for us to go through. But without this, it will be still, sort of, single-digit % of the overall hydrogen market in respect of the green energy. The other challenge, which we see in the industry through the lens of one of the suppliers, is the scaling up. Same thing. We're in the middle of 2023. If you look at all these hundreds of gigawatts by 2030, it's becoming a question. Can the industry cope with this increase in the demand? I can tell you, at the electrolyzer assembly level, yes. The lead time to set up the plant to produce electrolyzers, I would say, if it's a greenfield, we can talk about 6 quarters, if you're really going to go fast. If you talk about brownfield with existing people and processes like we did in Fridley in the US, you talk about 3 quarters. So it's fast. The biggest bottleneck is the supply chain and the components. And that's something which we tend to overlook as an industry, because unless the supply chain, and it's not just tier 1 suppliers, it's tier 2 and tier 3, will adjust to this massive demand, we will not be able to cope up with it. And by the way, we spoke about the position of the UK, in the hydrogen industry. That might be one of the good opportunities. It's just rather than thinking about these mega projects, just think about the supply chain. It's small, medium size of business. Might be good, socially. It might be good from the economics perspective, and there is a high demand for this. So this is the second thing which we need to address, and the third thing which we need to address is people. The lead time for development of an engineer who can deal with the hydrogen, 3 to 5 years. So we as industry need to partner with the universities and start to invest into the people now. Because then we look at all these ambitious plans with the huge projects starting from 2026, 2027. If we don't invest into the people right now across the globe, it's just not going to happen. It will be a huge hunt for the talent, which is good for the talent, but not good for the industry. And that's, by the way, addressing the discussions around UK. UK is known with the university space, so that's a great opportunity. But it's absolutely important that we, as an industry, invest in the people. We have this conference in the Museum of Science, which was opened in 1857, if I remember correctly. That was at the peak of the Industrial Revolution. And if you look at the names in this museum, behind the inventions, behind new products, and just think whether they were facing more difficult challenge than what we face today. The answer is no. Because the Industrial Revolution in the 19th century, it was very ambitious and quite complex project, and a huge change. It was much more dramatic in positive way, than whatever we discuss about the hydrogen technology. So, which should not make us afraid to make the next steps and be realistic, practical, and move on. Again, talking about UK. UK is famous with the quite interesting politicians. And there was one of the politicians was David Lloyd George, coming back. I think he was in charge, in the early 20th century. And one of the quotes, from him, is that don't be afraid to make big steps if you face it, because it's impossible to jump over the river, in 2 steps. So I think it's very clear what we are trying to do in the industry. We just try to go in small steps, while actually it's time for the big steps. And I believe we as an industry can make it happen. And then I say the industry, it's the component suppliers, it's electrolyzer manufacturers, it's the companies which are using hydrogen, it's the whole industry, and understanding the whole chain of the industry and what kind of steps we need to make is really important. Just to summarize, there is hydrogen market which already exists. It's a question, how to convert it into the green. There are tremendous opportunities to expand this market using the new areas of use of hydrogen, and we spoke about it during the conference today. Technology is not stable, but the industry continues to innovate. And this innovation is exciting, sometimes it's challenging, but it's happening right now. And we, together as an industry, can make a change. It's time for the change. Thank you.
Amazing. Thank you so much, Alexey. Some really interesting sort of context setting there for our discussion. Before we sort of get into that, I just want to remind everyone that if you haven't downloaded the app yet, get that downloaded. Pop your questions in for the panelists. They'll pop up on the screen and we'll try and answer them. And we'll also do a little bit of like sort of roaming mic. So if you can't get the tech to work, then don't worry, we'll get to you. But I just want to start off by offering our sort of other panelists just a chance to introduce themselves, tell us a little bit about what your company's doing in the hydrogen space, or perhaps what your role's been over the last sort of year in the hydrogen space, and sort of, I guess, sort of introduce yourselves a little bit. Perhaps we'll start with Chris.
Thank you, Claire. So thank you for having me here. I'm CEO of Progressive Energy. We're a values-based organisation whose mission is to take millions of tonnes of CO2 out of our energy system. We're not quite as old as Bosch. In fact, I thought we were doing quite well at 25 years old, but we're lacking the other 100. In fact, interestingly, we launched our first low-carbon hydrogen project of 800 megawatts 25 years ago. It's been a tough journey since then, but from that we've learnt an awful lot, and from that has emerged HyNet. So HyNet is a collaboration with other partners, so it is grounded on Eni's CO2 transport and storage system, and then partnering with Cadent in terms of hydrogen transport and Innovin storage. We have a key role in terms of hydrogen production. So the first gigawatt of hydrogen production from a CCUS-enabled plant, we're in a partnership called Vertex to deliver that. And we have a 200 megawatt pipeline of electrolytic-enabled hydrogen projects using a technology from my colleague to my left. I think the one thing I would say is HyNet is at its heart an industrial decarbonisation project, because we all agree universally, whatever colour of politics we are, wherever we are, that actually taking a big bite of CO2 out of our industrials gives us that really big early win, but it also provides us the foundation upon which we can reach out further. I'm sure during this panel we'll discuss it more, but just to give you the shape, within HyNet we have over 100 kilometres of hydrogen distribution, new hydrogen distribution being delivered by Cadent, and that will also connect 1.3 terawatt hours of storage, hydrogen storage with Innovin and salt cavern storage. I think sometimes we don't appreciate what hydrogen does for our energy system. To put that in context, 1.3 terawatt hours is the equivalent of taking every single passenger vehicle in the UK, 30 million of them, turning them into, say, a Nissan Leaf with 40 kilowatt hours of battery. That is still less energy storage than will go in that one facility that Innovin will be delivering in HyNet. That's the kind of thing that I think unlocks a hydrogen economy. I look forward to talking more about it.
Game changer. Thanks, Chris. Jane.
Okay, so I'm Jane Toogood. I'm the UK Hydrogen Champion. I was appointed last July, and that's a role really about helping to advise government and also industry on how to sort of accelerate the hydrogen economy, which sounds incredibly broad, but it's ended up being a little less broad than that. So I published a report, the government published a report in March, and that was giving some recommendations to try to accelerate things forward. And of course, we work across industry to try to bring projects forward, to make sure that actually the fundamental frameworks are in place to ensure that these first projects can actually get through to FID and actually be used in the UK. So I also have my substantive sort of executive role where I'm the CEO of Catalyst Technologies for Johnson Matthey. And Johnson Matthey is a sustainable solutions provider. In the context of hydrogen, we have technologies at the heart of electrolytic hydrogen production, so the CCM production. And I'm looking forward to a little bit of debate about the stability of technology in a minute. We also have technologies for the production of CCS-enabled hydrogen, and also technologies about the way you can then use hydrogen later as a building block for example, for sustainable fuels. So
Amazing.
with that, I'm going to pass
Thanks
over.
so much. Matt?
Hi everybody, good to see so many hydrogen folk here today. So I'm Matt Williamson, I lead BP's hydrogen business here in the UK. Whoever came up with the title for this session, Innovation, Challenge, Hydrogen Production, they are talking my language. On a food menu, I can't walk past custard or chocolate, and from business perspective, kind of innovation, challenge, hydrogen production, those are kind of three equally strong words. So I'd say that I've been trying to solve energy challenges for the last 27 years with BP. When I started, the challenges were around taking sulfur out of our petrol and diesel, so getting rid of acid rain. The challenges are arguably much, much bigger now, taking CO2 out of the atmosphere rather than sulfur, but I still get the same buzz of working with our engineers, working with our commercial teams to try and find solutions. So as BP, we're trying to walk towards this challenge rather than running away from it. So we are transitioning from a hydrocarbon business to a low carbon business, of which hydrogen is a key part. Alexey talked a little bit about innovation. Somebody explained to me, Matt, creativity is having new ideas. Innovation is actually doing them. And I think that what we're doing, what Chris has spoken about, is we are doing hydrogen production in the UK. So we're doing it in Teesside. Like Chris, we've got blue hydrogen, we've got green hydrogen. They're both great solutions for UK. And it is about industry. And I am unashamedly an industrialist. I've always worked in refining, energy business. It can be a bit unsexy working in industry, but actually the products that we love, cars, TVs, iPads, they all need industry to make them. And hydrogen is one of the great low carbon energy sources to help make those industries low carbon so that we can carry on buying all the things we like, but do it in a low carbon way. And I should say, in case anybody thinks that you're too narrow focus on hydrogen, hydrogen is only one of a number of low carbon solutions. So in the UK, we're investing in 6 gigawatts of renewable offshore wind, which is kind of 6 times bigger than what we're doing in hydrogen at the moment. And that's probably right. A lot of the answer lies in electricity, and hydrogen helps us to get to the parts that electricity can't reach. So very looking forward to the chat today. Over to you, Clare.
Well, amazing. I like to think that hydrogen is the sexiest part of low carbon,
Right.
so absolutely. No, I loved what you were saying there around, innovation is going out and doing it. And in many ways, everything in the hydrogen space is innovation, right? All of these new projects are doing something that has not been done before, and actually getting out there and doing it. I'm interested in particularly the sort of projects that you guys have got going on in Teesside and HyNet. What are the biggest challenges that you're facing where you actually need some sort of technology innovation or some innovation to sort of come in and sort of play a part in sort of getting these projects off the ground? There might be some other challenges there you might want to talk about at the same time potentially, but I won't tee you up too much. That's if we start with Chris.
Go on then. I have to say, I said earlier, the infrastructure is important. Actually, that is the biggest challenge. So, I'll be really candid. We sit here in HyNet. We have that 100-kilometre of hydrogen distribution, which is pretty much at the end of engineering and is just about to go in consent. We have the storage in a similar position. It was already consented for natural gas, has been changed to hydrogen and engineering. We are facing a 2.5-year pause if we don't get the business models right for hydrogen transport and storage. And I have to say that I see hydrogen transport as a huge enabler. It achieves all sorts of things. It means as a producer, you can reach a variety of users. As users, it means you can know that there might be a variety of producers that will actually be able to give you hydrogen. And actually for the government and for the UK, if you have some infrastructure, you will crowd in all sorts of new projects. Producers will go, we've broken that, chicken egg problem that we've talked about, because I know if I come into the infrastructure, then I can reach many users, so therefore it's financeable. So actually, maybe that's kind of business model innovation rather than technical, but I think it's there. I think the UK government's doing well to get a whole new business model away by 2025. Hats off to them, that's quite hard. What they need to do is make sure projects in flight don't pause, because we all know what happens. Let's keep them going, provide some funding, just enable things to keep moving.
Yeah, brilliant. Thanks, Chris. And what about you, Matt? What's keeping you up at night?
The hot weather. So perhaps, I take a slightly different stance on the technology, is that we've got these wonderful flat screen TVs around the room, and they are wonderful, but they still look a bit like the TV that I grew up with kind of too many years ago to remember. And so what we're doing is we're taking the best technology that is available today. Alexey's electrolysers are very good. They will be better in 5 years' time and substantially better in 10 years' time, but we can't wait until then. So, and I know Alexey says there's all kinds of choice and variety in electrolyser. There is around making hydrogen out of natural gas, but essentially, we do know quite a lot about the technology. So 27 years ago when I first stepped on a refinery, I was working on a unit that was using hydrogen every day of the year. So we know how to use hydrogen. People have been making hydrogen for years. So it's basically, for me, the challenge is taking the best technology we've got at the moment, that we know work, putting it together in a slightly new way. We're selling it to customers in an entirely new way. So selling hydrogen as energy rather than hydrogen as an input into other chemical processes is entirely new, and that's when you kind of get into challenges with government business models, with kind of people's alternative use cases, which is kind of using natural gas, great, but CO2 goes into the atmosphere. So we will do the best projects today that are available with the best technology today. We will work with supply chains, and we have been for a number of years trying to get people ready to make hydrogen projects happen in the UK. And those supply chains will get bigger, better, cheaper. And we are trying to push to larger scale projects, even if they're kind of like the first ones. That does bring kind of like investment risk, but it does allow you to get more bang for your investment buck. It allows us to get more CO2 out of the atmosphere for the same amount of pounds spent, which are all good things. So it's kind of like pushing the existing technology as big as we can within the government's investment frameworks. And I know that the project, the hydrogen projects we do that start up kind of like in 5 years' time, they'll be better, but the ones we do to start off with will still be great.
Amazing. I love what you said about, Alexey's technology getting, better in 5 years and better again in 10 years. Alexey, how good can this technology get? I know the US has come out with some sort of pretty ambitious targets around what it wants to get the cost of hydrogen down to. $1 a kilo, is it doable?
I believe it is. I believe it is. It will not happen overnight, of course, but don't forget that the big factor in the cost of the hydrogen is the electricity. Mm-hmm. So that's why the investment into the renewables at the lower cost, and also utilizing these renewables irrespective of the load, but based on the availability of wind or sun, I think this is something which will drive the cost significantly down. We know that in some high solar radiation regions, like in Saudi Arabia, north of India, Western Australia, you already can approach this number, even with the existing solar technology and the electrolysis process. So it's not far off.
Mm-hmm.
But can I just say, do not get this $1 number in anybody's head. It's so far removed from reality. And the places where you can make it are a long way away from where we need to consume it.
Yeah.
So I would say, and I've said this many times, I believe that we can make hydrogen in the UK at a lower cost than we import it for, and that's what our focus should be on the UK and trying to bring down those costs as much as possible.
Amazing. Whilst we're talking about the UK, Jane, I loved in your sort of report that the government published on your behalf. I don't know exactly what the sort of terminology is, but there was lots in there about UK strengths and building on UK strengths. I wonder if you could just sort of expand a little bit on that.
Okay, and I think actually we've heard a little bit about it, and we've got two fabulous examples here. A core strength of the UK is actually that we're working in clusters. And why, so in terms of innovation and challenges, one of the big challenges right now are these projects going through to FID. And one of the big reasons they don't get forward is because people don't have offtake agreements. Okay? But if you're working in a cluster, you're combining offtake and production, and so you're dealing with that immediately. And that's why when the World Economic Forum started to try to promote the concept of clusters, they used the UK as an exemplar of how to do it. And I think it's fair to say that actually the HyNet cluster was a really fine example of that and very well advanced. So I think that's a massive strength for the UK. I mean, it's obvious we've got the geology and we have the wind, that's very helpful, but it is very important. To your point, if you're going to be producing electrolytic hydrogen, it's electricity that actually is the bulk of the cost. 60% of the cost is the electricity itself. So you want to be making sure that you're optimizing everything for that part of the business model. And in that sense, we have the natural geographic advantage. I think, you talked earlier about things like universities and skills. We've got some fabulous skills in the UK. It's going to be very interesting as this all evolves, because skills and supply chain are going to be in shortage. And we can talk more about supply chains in the context of innovation, perhaps. But I think if you think about our oil and gas industry and the opportunity to effect some just transition and to help people to reskill, it is a really great place for them to go into this whole hydrogen space. And I think it also plays very well into things that we need in the UK, like jobs and so on, in areas where we also want that industry to be supported for the long term. So there are some really great natural advantages for the UK. I should also mention technology. I can't resist it because we have some fabulous technology, of course, and some brilliant technology providers. And we'd be remiss not to mention the fact that here's an opportunity for the UK to shine in a global context.
Of which Johnson Matthey is just one of many, of course.
Absolutely, absolutely.
I guess on that point on supply chains, it was interesting what you said, Alexey, about how the order book is full. And in many ways, that's a wonderful thing. In another way, that's also quite a sort of scary thing when we're looking at actually trying to build out capacity quite quickly and ensuring that we don't find ourselves in a position where we've got all of these electrolytic projects that can't get their hands on electrolysers for a decent chunk of time. What do we do about trying to scale up that capacity now so that we're ready for some of the ambitions that we have, not just in the UK, but globally?
I think, there are a few things which are important in that sense. I think clarity about the plans, I think we already have. Yes, we might debate if these plans are realistic or not, but I think, Europe formulated the plans, US, UK, even India now has a plan to produce 5 million tons by 2030. So I think it's more or less clear. The question is how to align these plans to the I would call it last bolt and nut. And my biggest worry is not so much the big components. I think rectifiers, membranes. So we deal with the big companies. And that's where we can align our plans and forecasting. But then we go to the smaller components. That's what keeps me awake at night. That one day in 2025 we'll wake up and we'll just missing some sort of stupid nut. But it will not be available in the industry with a lead time to set up manufacturing, say, of 3 years. That's what I'm worried about. So I think it's a question of the industry having the visibility of these bottlenecks and then communicating these bottlenecks so the companies which are interested make proactive investments.
And is there more that we can be asking the government to do, or the government should be doing, to try and foster an environment where technology innovation is easy to do or is encouraged? Is there more that we'd like to see from government around sort of technology innovation and potentially opening up some of those barriers that might exist at the moment?
Can I go?
Please do.
So look, I think I want to build on your point here about the supply chain and what's critical in the supply chain. So coming back to the piece about innovation, and innovation is the deployment of the technology. It's not just the R&D of the technology. And exactly as you were also saying, basically the technology itself, it's good actually. It's totally deployable today. And just like every other sector, it will keep evolving, and there will be further R&D, and we will get further efficiencies, etc. What is critical is that we make sure, in terms of supply chain and innovation, and particular technologies within that will be critical, is that we identify, with industry's help and across government, where could the UK really make a difference? Where should we invest, and then get behind those parts of the supply chain, the value chain, and really support those? It sounds easy conceptually, but it isn't quite so easy, because of course you're dealing with different people who are competing, and you're also dealing with different perceptions around how the supply chain would evolve. And to be precise about what is it that's critical that the UK is really strong at is not so easy either. But we do have some work going on, some working groups that are actually looking at how can we identify parts of the supply chain. I think actually,
yes,
here you
we
are,
might have some of those.
Claire, the moderator.
Yes.
I think you could actually say a few words about that too. Sorry
Yeah,
to flip it back to you, but
yes, I'm being questioned. Yeah, no, this is a bit of work that we've just kicked off as Hydrogen UK. I realise I haven't actually introduced Hydrogen UK yet today. We're the sort of trade association that sort of bring together all the companies that are super excited about the role that hydrogen can play in delivering net zero, and are sort of committed to making it happen here. Absolutely, to sort of Jane's point, we want to make sure that the UK is not just a global leader in the deployment of hydrogen, but also in the development and manufacture of hydrogen, so that we have that supply chain and we have that value chain sort of anchored here in the UK. And so we have just kicked off a work stream which we're going to be looking at which parts of the supply chain do we need to sort of prioritise in the sort of immediate term. You know, where are those purchasing decisions going to be made in the next sort of 2 to 7 years? Looking a little bit at sort of supply chain dynamics, then what do we need to do to try and anchor some of that here in the UK? Anyone who is out there who perhaps makes bolts or has some sort of thoughts or wants to be sort of part of UK supply chain, please do get in touch with myself or anyone from Hydrogen UK. There's a few of us knocking around today. We'd love you to be a part of that process. Is that enough of an advert for that, Jane?
But it's really quite important. The UK is not going to be brilliant at everything.
Yeah.
You know, that's quite clear. And we need to make sure that we're competitive, we can access multiple sources, etc., etc. But we need to make sure we're behind those things where we can make a difference. And we definitely see others putting effort into that, and specifically requiring content, for example, in the projects. And I think there's a real debate to be had around that. So it's quite an important
Chris?
point.
Yeah, and I think the other one I would come back to is, I mean, again, HyNet, we have a supply chain group doing the same kind of thing. It's really important. But the other thing is deployment of those projects is consistency. It is pace and ambition, because actually what the supply chain can't do is ramp up and then be put in pause. And I mean, history of things like the RHI ending up with a very lumpy sort of demand because suddenly new rounds of projects come out. That's not good for the supply chain. The supply chain needs to build and be consistent and know there is a steady train of projects coming through. So it is circular in that.
And that's where that production roadmap that Katie was talking about this morning is hugely helpful, so that industry and supply chains have sight as to when allocation rounds are going to happen, what sort of capacities are going to look like, and perhaps a little bit more information on cluster sequencing and those kinds of things will be sort of hugely helpful. So yeah, hugely agree with that. We've got some questions coming in, which is fantastic. We'll also sort of come round and have some on the handheld. So why don't we start with this one? What innovations are the panelists most excited about? I don't know whether, Alexey, you want to kick us off with that?
Yes, I will comment on this one. The innovation I feel extremely passionate about is slightly beyond the electrolysis, which we deal with, But if you look at the wind turbine industry, the way the wind turbines are calculated, it's not so much based on the maximizing the input from the wind. It's calculated based on the grid requirement. So while if you design it in a way that you take the maximum power out of wind, irrespective of the load, and then you can utilize hydrogen as a storage to take the excess, the whole system becomes much more efficient. It's technically challenging to merge two things. It's also offshore primarily, but that's one of the innovations which is currently discussed in the industry and going on, which I feel extremely excited because I believe it will drive the cost down.
Amazing. Who wants to come in next on what's getting you excited? Come on, Jane.
You can't
Jane.
stop me on innovation, I'm afraid. No, but I suppose, look, apart from actually getting stuff deployed, which I'm obviously really excited about, and I'm sure we'll all agree, one thing that I'm very interested and excited around is the recycling of the CCMs at the heart of the electrolyser, because I think this is all part of making sure that you have both, an efficient use of very critical resources, making sure as well that you're doing things in a more sustainable way. So this is beyond the CO2 footprint, and it requires innovation because you're looking at materials that have not been deployed in that way in the past. So I think it's a really exciting piece of innovation.
Amazing.
Matthew?
Well, so I'm sure everybody thought most innovative thing in the UK is pipes, didn't you? But
I love a pipe.
Actually, I think some of the activity around reusing our pipes instead of using them for natural gas, using them for hydrogen, is really important for us. So BP's view of the world, it will be wrong, but it's not a bad shape, is that by 2050, globally, we'll be using 60% less gas than we are today. And in this part of the world, it'll be an even more significant reduction in gas. That means we're going to have loads of spare gas pipeline capacity. And we can use that to transport hydrogen energy around the country, which could be a much easier way to transport energy than building out a lot more electrical networks. And so what I love is just the simple fact of companies going away and testing old bits of pipe, old fixtures and fittings, new pipe, new fitting, to work out which of those pipes can already today effectively carry hydrogen and which would need to be replaced. And hopefully that means that one day, not too distant, we can get hydrogen from one end of the country, and in Scotland we've got loads and loads of renewable power, which we'd love to convert a bit of into hydrogen, and that could end up maybe in this part of the world going into a factory making innovative products here. So, yeah, pipes. That's where the innovation is. That's where the excitement is for Matt.
Great, thanks, Matt. Chris?
I think that's brilliant. That's so. Funnily enough, I was going to take an angle. Actually, it is that system view. Look, the foundation of net zero is going to be renewable electricity. No doubt about that. Probably 50% of our energy flows are going to be that. But you can't bunker an electron. You just can't. And the fossil system has given us a way of managing both long-distance transport of energy, but also managing supply and demand. And a molecule of hydrogen does exactly that. And I think as we see our electricity systems and our gas systems, and then our wider oil systems all working together, we've not seen that before. They've been very separate, and I think coming together is good. And the other one, a bit like Matt, I must admit, having watched places like Pilkington convert their furnace and run it for a trial on 100% hydrogen, there's something really visceral about seeing a real large-scale plant actually trying it and doing it. And the confidence that gives not only to the board of that particular company, but to other companies looking on, that, okay, this is actually doable. I think is important.
Amazing. Seeing is believing, right?
Yeah.
Amazing. Well, we'll see if we've got some questions in the room. We do have some more on the screen. They're all sort of coming in, but it's always nice to hear from the audience directly. Has anyone got a sort of question in the room? If you could just pop your hand up. Is there any? Sorry. Yes, with one at the back there. Yes. Sorry, I can't see you. It's quite dark in here.
It's me again.
Oh, yeah.
This question is to the BP gentleman. I mean, I personally have contacted BP, but they never get back to you. And
now's your chance, Matt.
They talk a lot of, I call it nonsense regarding, we're into innovation, we want to do this, we want to do that, but they never do. In any case, you made a comment about, that $1 cost of, let's say, a kg of hydrogen. Actually, the Americans, my good lady, was talking about $2, not $1. per kg. But even at $2, how are you going to achieve that with these outdated technologies that BP is fostering? Because it's impossible. You cannot do that. The cost is somewhere close to about $15 or maybe $16. And that's going to continue. It's not going to come down. You're not going to get your intermittent, unreliable solar or wind at a cheaper cost. Not much cheaper. I mean, so that cost is going to remain there. Today we have technologies. I mean, we can produce a kg of hydrogen at lower than 10 kilowatts per kg. But you guys don't want to adopt something like that. You want to continue with that intermittent, unreliable solar or wind. The problem is you need to learn about how electrolysis can actually happen. What do you need? What are the components that you need in your electrolysers? For example, you're going to need highly conductive electrodes. You're going to need magnetics, triple layer magnetics. You're going to need acoustics. You're going to need a clever power management system, which you guys are not actually adopting any one of that. Your technology is outdated. So how are you going to achieve that to $1 that you were claiming?
Great question there around, how are the costs of hydrogen going to come down? Probably not just a question for Matt there, but for everyone around, what are the things that we're going to see adopted that are actually going to bring cost of hydrogen down? Don't know who wants to sort of comment on that one first.
Well, let me start, given where the question was directed. So very happy to have a chat about new technologies. We would say that we are technology agnostic, so we're not just going to produce green hydrogen, we're not just going to produce blue hydrogen. That's where we're starting. So the things that are going to impact the cost, Alexey, I think already mentioned it, the cost of power when it comes down to producing green hydrogen. The cost of power is the biggest cost input. And that will come down through the right mixture of renewable sources. So mixing wind and solar is an effective way we're finding to produce greater or higher load factor for electrolyser. There will be, the UK is already going through a huge transformation from a renewable power perspective. That will continue, and over time, that will lead to lower renewable power prices. Not today, not next year, but within the foreseeable future. That will help us from a hydrogen production perspective. And there's quite a lot of cost that comes even after you make the hydrogen to get it from where you make it to where it's consumed. And as we build bigger hydrogen facilities, better connected to more customers, that kind of that logistics part of the hydrogen value chain will come down as well. So I don't think we're going to be at 1. I don't think we're going to be at 15. We're going to be kind of in the middle and coming down. But yeah, as before, we start with what we've got today, but every new project we do will be better because there will be better technology or there will be lower cost energy inputs. But we're not going to wait until we've got the perfect solution. We're going to start with what we've got and make it better.
Maybe if I can jump in before, I'm sure both our technologists will want to. I think that scale issue is really key. And again, not everybody agrees, but I take a very firm view that CCUS-enabled hydrogen allows us to get some scale and rapidly. Because we're already short on renewable electricity in this country. So there is a job to build that up in order to satisfy that demand. We must at the same time do green hydrogen in order to build that supply chain and get projects going. But to get real volume to enable the infrastructure to take place, that's where the CCUS enabled hydrogen does get you there. I've got both technologists on both sides of my project. So we talked about the green hydrogen, but Vertex, the first line, is using Johnson Matthey technology. And we are talking 97% capture rate. So that's great, that's fantastic, that gets us going, we need to do it. And that, if you take government assessments of of hydrogen costs. Admittedly, a few years ago, they tend to do it in pounds per megawatt hour. But, you're talking sort of 60, 70. So you're talking, £2, £2.50, even for relatively early projects, is doable. And as we say, in the same time as that electrolytic, as the cost of electricity comes down, and as the technologies develop further, you can start to then bring the electrolytic hydrogen into that range and below.
Amazing, thanks, Chris. Either of our technologists want to weigh in on this one?
Go ahead as the host.
Okay. Well, we have hydrogen summit here, but I think I need to say a couple of words in defense of our colleagues in the renewables. I cannot say that they're intermittent and unreliable. And what I would encourage everybody to do, there is a absolutely great app which is called Electricity Maps. Just download it and take a look, and you will be surprised about what kind of role renewables play already today, especially in Europe. Because it's a data, and it's a real-time data about the wind, solar versus coal, nuclear, and you can see country by country, including the energy flow between the countries, import, exports, and so on. And once you look at this data, you will see that the renewables already play a tremendous role in the electricity balance, and it will play more, and there is room to grow. And you can also clearly see that these fluctuations of the renewables, they currently are compensated by coal and gas. That's how it happens. And what we are talking here is about future replacement of coal and gas with hydrogen, which is carbon neutral. So then we talk about the cost. The renewables, whether it's solar or wind, it's a high capex, low opex type of installations, unlike the coal or combined cycle gas turbine type of power plants, or even nuclear. So it's a different kind of economics. I'm not saying that we need to massage the numbers, but it's different. And there is also a geography factor, which is related to solar, but also to the wind. So it's a question for the industry how to reduce the capex for solar and wind solution, and also making sure that these solutions are placed in the right geographies, which will generate the lowest cost of the electricity. And the factor, the cost of the hydrogen is actually factored by the electricity cost to a large degree. The only thing what electrolyzer is doing is just converting electricity and water into the hydrogen and oxygen. It's conversion. Yes, we are working hard on the innovation which will improve the efficiency of this process, but the biggest deal is the cost of the electricity in the system. That's what it is. So I'm very optimistic. Again, we can debate what will be the number, and when it will happen. But using the analogy with the solar industry and with the solar panels, just look at the cost reduction of the capex in the last 10 years. I don't remember. I'm speaking from my mind, but I believe it's up to 10 times lower than it was 10, 15 years ago. So there is a trend. Obviously, it's going down. And exactly to address what Matt was saying, the technology is evolving, and yes, we can think about perfect solutions in the future, but unless we start to invest and innovate today, well, it's a journey. So we need to go step by step. So I think the question is really good because it generates good debate, good thinking, and also it might generate some of the different kind of ideas which will generate through the innovation process. But I don't think we can think about that things will change overnight. It's a journey. It's a question to be on the right trend.
Okay, so this whole question about cost and a single cost for hydrogen is, I don't think it is an easy answer to this one. So first of all, incontrovertibly, we will need hydrogen as part of the energy transition. We can make hydrogen today. It's used already today, of course, in refineries, etc. So it's not new to handle, etc. And we know what the cost of doing that is. But the trouble is, it's carbon emitting, and we just can't keep going like this. So we have to invest to make sure that we go through the learning curve. I mean, that's just the reality of life, sadly. And we're going to go through this industrial revolution. It is so difficult to estimate what the impact of learning through scaling is going to be. There are many models, of course, that give you the opportunity to do that. But fundamentally, if we don't go through doing these projects at scale, we will not get the learning and we will not get to the cost reduction. So you have to have the support, and of course, as the questioner, I'm sorry, I can't see him, but will know very well. I mean, the reason you get to that low cost of hydrogen is because basically it's funded by the US government. So that's how you get there. It's not to do with the technology itself. It's nothing to do with that. What we do have to do is to keep looking for the next generation and the generation beyond it, but we have to be going through the scaling up mode. So we have to have the big CCS projects and we have to have the big electrolytic hydrogen projects, notwithstanding that there are some very small ones that work very nicely actually on an ecosystem basis. But if we're going to really drive a future where hydrogen is at a better levelized cost, you have to get the big, gigawatt scale type projects going. At the moment, of course, as you know, these electrolytic hydrogen projects are sort of 100, 200 megawatts is a really big one.
Amazing. Well, we're pretty much out of time now, but I can see there's a few more questions that have come in on the screen. So just sort of encourage you, if you didn't get your question answered, I'm really sorry, but the panelists, you can novel them afterwards and ask some of the questions that you've still got remaining. I think this has obviously been an absolutely fascinating discussion. I feel hugely encouraged around the innovation that is already happening here in the UK and around the world, and there's a lot of hope for getting costs down and getting things moving. And I just ask you to sort of join me in thanking our wonderful panelists today.